So in this video, I will be going through the 3E end of year paper 2 2019, and since I have covered some of the question in class, I will be starting with question 12. So I think in question 12 I told you that I have I finally come up with a method that can save all of you, right? So let's say down here I am given a question, and because this is a scan script from one of the students, so I will just mark out originally what the question has provided for us. So if the student has not attempted, these black color lines are what is given to you, and you are supposed to form the entire ray diagram. So what if I have no idea how to solve this question? So what you need to do is, number one, you need to quickly identify whether the image is virtual or not. Because when we draw ray diagram, there are two types. The first type will be the virtual one. If once you know that it is a virtual type, then basically what you can do is you can quickly sketch out the kind of ray diagram that you would expect to see. So you would expect that on the right side, the rays will not merge, but actually when you apply reversibility of light, the virtual ray will actually meet at one point. So this is the standard virtual ray diagram. So once you are able to do that, what you need to do is that you sketch the rough one on the side. And you can actually see that for any ray diagram is made up of 7 points. So you can see that this is point 1, point 2, point 3, and point 4, point 5, point 6, and point 7. And then once you sketch the template ray diagram, so once you know that it is virtual, right, you can sketch the template ray diagram on the side. Then you compare with what you are given. So down here what you are given is, let's say this point would be point number 4, then point number 1, point number 2, point number 6, and point number 7. So you look at what you have given by the question and the template ray diagram, and you ask yourself, now that I have this few points, what are some of the points that I can construct? And I think quickly you can see that, oh, I can actually make 2 to 3, right? So immediately you can then write 2 to 3, and you find that by doing so, I will be able to locate point 3. Then you may ask, oh, maybe I can draw maybe 3 to 5, but 3 to 5 requires you to know the focal point, but you are not given, right? So if you are not given, then you need to keep searching. What are some points that you can find? And you will be able to see that, oh, okay, it is given 3, 7. So then you can quickly draw 3, 7. And once you draw 3, 7, you will see that actually 3, 7 will be able to give you this straight line. Will be able to give you this straight line, which will then enable you to extend it and be able to locate point number 5, which is the focal point. And then if you keep looking, that means you can then draw 2 to 4. You can also draw 2 to 4. And then after that, you can also draw 7, 2, right? So you see, just by being able to sketch the template ray diagram and compare with what you are given, you can basically solve all kinds of questions. So in this video, I will be going through some other question about ray diagram to teach you this method, okay? But just in the spirit of completing the question, very importantly, all solid line should have an arrow. Dotted lines such as this shouldn't have arrows, so this student will get penalized 1 mark or half a mark, I do not know. Yeah, and you should be able to measure the focal length here. And if you measure it correctly with the correct unit, you will get the full 3 mark. So one application for this, it is not funny mirror, unfortunately. So do read up on your textbook to find out for a lens that can give you virtual image, what are some application. Okay, this one is just whether you have studied your text or not. So for the remaining video, what I will do is, oh, okay, there's the last one, right? Determine how far the object should be placed uh, from the lens in order to obtain a real image. Okay, okay, maybe I go into part C first. So for part C, what you need to know is that there is actually this diagram in the worksheet that tells you what your object distance is in order to produce a certain kind of image. So let me refer you to that particular worksheet. I believe it is in light. So let me search for some light worksheet here. I hope it is given here. Let me see. Light. Oops. Light. This is kinematic, sound, wave. Where's my light? I see one light. Oh, light here. So this is light. Yep. So if you refer to worksheet 12.3, so worksheet 12.3, if you see page 3, basically what you can see is that when the object distance is at, let's say, 2f, you will be able to get an image that is inverted, same size and real. And if you place the image at between 2f and f, you will get an image that is inverted, magnified and real. So actually there's this table given here on page 2. What it says is that if you go and put your object in this green area, you are going to get an enlarged image, a virtual image and an upright image. If you put your object over here in between 2f and f, you will be able to get a enlarged, real and inverted image, so on and so forth. Okay, and this particular thing will also tell you that if you place your object at exactly 2f, you would get a same size image. So I think just now in that question, they are asking you how far you should put your object so that you got a image that is of the same size, right? Well, place it at 2 focal length away from the image. Okay, so basically if you refer to these worksheets 12.3, you will be able to actually find all the information you need with regards to where you should put the object in order to produce certain kind of image. In essence, the image property, right, there are only 3 classification: enlarged, diminished, same size, inverted or upright, real or virtual. So by putting it at different object distance, you will get different image property. Okay, so for that would answer your is it this question? Yeah, so that would answer this question. If you place your how far you should place your object from the lens in order for the image to be of the same size. So in this case, the student answered correctly. You take the focal length and then you multiply by 2. Yeah, so in this case, yeah, the same unit as well. So you need to memorize this chart. So let's go back to the gist. How can you show, I'm sure you are now thinking, can you show me more example on how to use a template ray diagram to solve all kinds of questions? So I feel that it is a valid question, and we can go back to some of the questions that we have done on ray diagram. So let's see, where is that? Yeah. This is thermal light. Okay, I see light. Give me a minute. So this is light. Okay, this one has a lot of ray diagram. Okay, no more ray diagram. Okay, so let's say this is given to me. Okay, let's say this is given to me, and I'm very weak in this. I suck at this. Okay, so step number 1, real or virtual. So let's decide whether this is real or virtual. So here, I do not know whether it is real or virtual, but judging from the way that the answer is presented to me, I can see that there's very little space over here to form any virtual image. So I would guess that this particular template that I'm going to have is the real case. So it will be an object here, and then I would expect the image on the other side. So I will draw roughly, it will converge, and then I would have an image here. So in total, 7 points, right? 1, 2, 3, 4, 5, 6, 7. So let's call this 1, 2, 3, 4, 5, 6, 7. Once I do that, I label the corresponding thing. I have 1, I have 2, I have 4, and I have 5, right? So what can I construct? So you look at what you have, 1, 2, 4, 5, and then you look at the template. So what can you connect? So maybe you can connect, say, 2, 4. So you can connect 2, 4. So you could just connect 2, 4 lah. 2, 4. So, okay. Then what can you do? Oh, maybe you can construct 2, 3. So 2, 3, here you go, 2, 3. So you will have 2, 3. So now 3 is exposed. So what can you connect? And you look at here, you look at here. What can you connect? Yep, you can connect 3, 5 right here. You can connect 3, 5. So connect 3, 5, and you will get this. And if you extend the line, well, basically you have exposed 7, and once you have 7, you can then go and find your 6, and you have completed the ray diagram. So easy or not, this method? Well, correct. So what if you say, teacher, but this one you have been given the 1, 2, 3, 4, 5, you know? What if you are given like nothing? Can you solve when you are given like nothing? Okay, so I found one nothing one. Okay, first, always ask yourself what type of template you need. Real template, quickly sketch. Find space, sketch it. Right, so here you sketch. Oh, yeah. So you sketch, and then you have this. Right, so once you sketch, label it 1, 2, 3, 4, 5, right, 6, 7. You will notice that it is always 7 point. Then what do? Well, now you have nothing, so you construct from the beginning. So definitely you will need a principal axis, right? So draw the principal axis first lah. Image distance is 8. So image distance is 8. That means I would have a lens. Then it will be 8 cm from my lens. So now I know that, okay, I would have an image somewhere here. So I will help myself by labeling everything, okay? And I will take over here that I've used the data. Then I have an object height that is 4 cm. Object height 4 cm, meaning that I don't know where's the object, but I know that it is 4 cm height. So I will do this, and I will know that my object will reach this line, right? This is my object height. Right, so this is my object height, 4 cm. Right, then after that I have my image height 6 cm. So I have my image height 6 cm is here. I got this. So this is my image height. Once I have this, basically I will just do my points. I will have what point? You can see I have this point, right? So I have that point. So this is point number 3. Of course, I will have my optical center point number 4. I know my image is right here, so I got point number 6. I know my image will be here. It will be point number 7. And this means that actually I can draw my image already. And basically that's all I have. So what can I link? So I look at 3, 4, 6, 7. So I focus on this lah. 3, 4, 6, 7. Well, I can see that 4 and 7 can be linked. So I draw 4 and 7. No? 4 and 7 can be linked. So I draw 4 and 7. Hook. 4 and 7, right? Then after that, it will expose this point. This point looks like it's my 2, right? So this is my point number 2. So once I know point number 2, it means that I can find point number 1. Right, so I have point number 1. So what do I have? Oh, I can also do 2 to 3, right? So I will do 2 to 3. 2 to 3 will be like that. I have done 2 to 3. What else can I do? Can I do 3 is to 5? Nope, I do not know where is 5. But I know that 3 will cut 5 and then it will reach 7, right? 3 cut 5 goes 7. I do not know where is 5, but I know 7. So I can do 3 is to 7. So 3 is to 7. And I can get my focal point. Yeah, so do you now see the power of this method? It turns your ray diagram into a dot and line diagram, a dot and line game. Okay.